So now I'm going to present to you a rearrangement reaction. So rearrangement reaction occurs when a molecule undergoes changes in the way its atoms are connected. So in rearrangement reactions, we have 1-butene reacted with acid catalyst producing 2-butene. So here, acid catalyst makes changes to the 1-butene that results to the rearrangement of its carbons and hydrogens. So as a result, due to the condition brought by the acid catalyst, 1-butene turned out into a 2-butene. So as you could see, or as we observed, there is no changes in the molecular formula because the number of carbons in 1-butene is 4. This is the pairing chain. Let's count 1, 2, 3, 4. And the number of hydrogen here is 8, which is 1, 2, 3, 4, 5, 6, 7, 8. Is also the same to the number of carbons and hydrogens present in 2-butene. So let's count. We have 4 carbons. This is the parent chain of 2-butene. So let's count 1, 2, 3, 4. And we also have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. So with that said, we can say that it's just an atom rearrangement occurred. So that concludes my example in rearrangement reaction. Thank you.
Rearrangement. There are many types of rearrangement, but we will use Hofmann rearrangement. Hofmann rearrangement is convert amide into amine. For example, we have pentanamide, which we can draw as 1, 2, 3, 4, 5, then the amide, which is NH2, then OH. We need a reagent to use, which is bromine mixed with water. Bromine mixed with water. Then the formation will be, we will just get rid the carbonyl group, and we will use this and the NH2. So the final product will be 1, 2, which is NH2. This is now the amine, or all known as butylamine, plus the CO2 that leaves to form under alkaline conditions. So this will be the final product for the rearrangement.
In rearrangement reaction, we have here benzamide interacted with bromine 2-aqueous sodium hydroxide to the product of aniline and carbon dioxide. When the substrate benzamide reacts with the reactant bromine 2-aqueous sodium hydroxide, the ammonia will attach to the benzene ring, producing phenylamine, which is aniline, and the carbon double bond oxygen will detach to the benzamide and separate as a carbon dioxide as a product.
The rearrangement. It is a molecule that is rearranged to give a structure isomer to the original molecule. Like for example, I have here the propylamide. So we just need to remove the carbonyl group to form an amine, which is you need to remove this carbonyl group to form an amine.
In this video, I'm going to discuss to you about rearrangement reaction using an example. Let's say we have one hexene. Due to the presence of acid catalyst, it created changes on the arrangement of carbons and hydrogens, therefore forming another compound called 2-hexene. However, in terms of molecular formula, no changes occurred. You might be asking why 2-hexene. As you can see here, when we count the numbers from the left to the double bond, it stopped on the second carbon. You can also see that there are 6 carbon atoms, 1, 2, 3, 4, 5, 6, and 12 hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because it has a double bond, it's an alkene. Therefore, we have 2-hexene.